So when we look, at circles, like we have for so many things when we're dealing with this stuff, we're going to have a formula for this. Now, at first, this formula is going to seem kind of complicated, but when we take a little bit deeper of a look, it won't be as bad as we may think. So I look at this and I go, oh yeah, Harty looks a whole lot better. Basically what I'm looking for in here are two things that would help me either draw a circle or figure out what the equation would be. And those two things are the center of my circle, which are going to be the opposites of these two values. Now, why would it be the opposite? Because you notice here it says x minus h, or x and the opposite of h, and then y and the opposite of k, and then r stands for my radius, the radius of my circle. So if I know these two things, I can draw any circle that may come my way. So I look at number one, and I go, well, it kind of looks like that equation, but I don't see any parentheses or anything. So here's something you can do if you like consistency. If I don't see a value with x, or I don't see a value with y, I can always put a minus 0 in for those. Now I don't have to, it's just assumed, but that's another way I could write this specific one. And that may help have a couple of bits of the information come out a little bit smoother. So I look at this and I go, okay, my center is going to be at 0, 0. Okay. So center's going to be here in the middle. Then to find the radius, there's one little twist. Since my radius, this says this is r squared, I just want r. I just want the radius. So I take the square root to get rid of the squared, and I find out that my radius for this particular one is 4. So you're like, okay, how do I use the radius to make the circle? You know, we don't have compasses, protractors, all that stuff. What I'm going to do is I'm going to go 4 each direction out from where I'm at. So I'm going to go right 4, up 4, left 4, down 4, and then do my best to connect the dots in something that at least semi looks like a circle. May look more like a flat tire, but let's hope it looks more like a circle than it does a diamond, okay? Because we are trying to draw circles, and that's it. And so what we'll start to be able to see as we do these is a pattern is going to develop that we can start figuring out what the shifts are of these. So I look at the next one. After this one, I'm going to have you guys see if you can come up with the next couple. Okay, my center, remember, like we mentioned up top, it's the opposite of what I see with these numbers. So I see -3, so I write 3. I see +4. I write -4. And I go plot that point, so right 3 and down 4, and you're like, hey, that's kind of like when we did absolute value with these. My vertex worked the same way with these shifts and stuff like that, and it's true. Circles work the same way in that this tells me how far I'm moving my center left or right. I started at 0. I went right 3, and I went down 4. Same idea. My radius is always going to be what the square root of this value is. So my radius is going to be 2. And so from that first dot I made, I'm going to go 2 in each direction. And again, try to do the best job I can of making a circle out of this. Yeah, I was going to say, sometimes when you're first doing this, it can look like flat tires, squares, all sorts of other strange things, but we get there. Okay, let's kind of see how we're doing here. Okay, so on number 3, anybody care to venture a guess where the center is going to be at? Nice. Okay, 0, because I don't have a value with my x squared. 0, negative 1. So I'm here. I go down 1, put my point. And my radius, again, is the square root of what's on the right side. So in this case, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5. I get that worked out. And again, once I get those, just do your best to work that around. You're like, okay, I'm kind of seeing what we're up to here. This isn't too big. So let's see. What about 4? What's my center? Okay, 4, opposite of that. 0, since I don't see. And my radius would just be 1, because the square root of 1 is 1. So write 4, put a dot. And then just 1 away. This is going to be a really tiny circle. Kind of scrunched up here. But the basics are still all the same with these. So that's how we go from equation to drawing. So then sometimes maybe we won't have to do a drawing. Just identify the center and the radius. So again, all you've got to do, opposites of both the values I see in the parentheses. So I see minuses, so I make them positive. And then again, take the square root of whatever's on the equals side. And that's going to be true. Opposite of positive 12 is negative. Opposite of positive 8 is negative 8. And take the square root of 49. So you're like, okay, so they give me equations, I can get all that information, I'm good with that. But what happens if they want us to go the opposite way? If they're willing to give me the information and they want me to come up with the equation. So again, I've got the page up at the top to make reference to. So I can look and I'm like, okay, I got this. So it's x minus, again, my centers, my h and my k. So x minus h squared plus y minus k squared equals my radius squared. And I can simplify this a little bit, so I will. Because the formula itself, I'll be back down in just a second. When I start with these is, on the right side, it's always radius squared is when I'm making the formula. So sometimes it can get a bit confusing when I'm going from the formula and graphing, where I'm taking the square root, to now, where we're actually squaring it. So x minus 0 is just x, so I could write x squared. Y minus 0 is just y, so I put y squared. And then if I need the calculator, I can go ahead and hit 14 squared in there, which is 196. And that's my equation. Somebody'd be able to draw this circle from that. But if I actually have a center, I need to use that. So, x, what happens x minus negative 6? What happens when you, yeah. Yes, nice. You want to keep rolling? Keep rolling. Nice. Nice. 6 squared is 36. Couldn't have done it better myself. So just keep remembering on the center, it's the opposites of what I see, and that I need to square my radius. Okay. Nicely played, nicely played. Now, here's where life can get a little more interesting. Like, oh boy, life more interesting. That can be scary. Let's flip over. What happens now? They changed the information on me. They said, okay, we'll give you the center still, but now we're going to give you a point on the circle. We're not going to give you what the radius is. You're going to have to figure this out. So if that happens, okay, so to find my radius in this case, we want to find the distance from the center to a point on the circle. You're like, so I got to figure out how far it is from the center to that point. And that would be true. So here's how we're going to do that. We're going to use the distance formula. We're going to kind of have a flashback here to geometry for a minute. So if it's been a little while, to find the distance, we subtract our x values and square them. We subtract our y values. Oops, let me move that down a little. And square them. And then we take the square root of that. So when I actually have to do this, it's not going to be real complex once I have my formula written down and situated. So I'm going to scooch this a little bit because I'm going to keep writing it as we do these problems. So here, my distance, or my radius, let's change that. My radius, oops. So I take my x's, and it doesn't matter which order I do them in. So -9 minus -8, well, minus a negative makes that plus. And then I do the same thing with my y's. -16 minus -16, which makes that plus. And then I work this out. Now, here's the one thing that I would suggest. Before you try to type the entire thing into the calculator, I would just look, and if I needed to put these parts in, I would, but -9 plus 8, okay, still in parentheses, is -1. I think you're going to find we might not need the calculator. -16 plus 16 is 0. And so I look at that, and I'm like, well, that'd be 1. So 1 plus 0 would be 1. Okay, so the radius is 1. I've got that part. So am I done? Well, no, because I want the equation. You're like, oh, so I got the radius now. I got the center. I got what I need now. I got to have those two things to be able to find this equation. So x opposite of h squared plus y opposite of k squared equals my radius 1 squared, which is still 1. And we're in good shape.
Is it okay if, like, on the next slide you have us like write the equation out as well? Is it okay if we just read it like the radius squared, or do you want like actual one?
That's a good question. So can I leave it as radius squared, or do I actually want the number? I'm actually content with either.
Okay.
Yeah, I'd be okay with either of those. Okay, one more of these because I want to make sure this part's okay, because this is like where that's the most math work we've got to do. So, okay. So one more time on these guys. So again, take my x's, -4 minus -6, because that becomes plus. And then y minus y. Again, and it's critical I keep my parentheses on these. So when I get to this next step, -4 plus 6 is 2. 5 minus 3 is also 2. So let's see, that's 4 plus 4, which is the square root of 8. Now this is one of those times that when I go to write the equation, it might be more helpful to somebody who's looking at this to see it with it squared out with my radius, but we'll see. So there's my center, got my radius. X opposite of h then y opposite of k. And when I take a square root and square it, the squared and the square root are opposites. They just cancel each other. So if I did square my r, it'd just be 8. Now, for now, we're going to skip 11 and 12 because I'm going to go for quantity here. So if we scooch down a bit, what if they just give me a picture and they want me to come up with it? This is actually one of the easiest ones. So I mark my center and I go, okay, where's my center at? 4, 4. So my center's at 4, 4. And my radius is 1 because from the center out to the edge is 1 square. So to make my expression, x minus h, or x, and then the opposite of h, plus y, the opposite of 4, and square my 1. And so I just go wherever my picture is, I find the middle, I label that point, I find my radius by going from the middle out to the edge, I go, okay, equation, x opposite of h, y opposite of k, and square my radius. 3 squared is 9. Okay. So you're like, man, there's a lot of ways you can do this. The last twist that can get thrown at you, last one. What if they do a translation? Now, translation is a fancy way to say shift or move. So here's how this works. I'm going to write down my center. And 5 up. Does 5 up affect the x value or the y value if I'm moving up? Y. So if my y value shifts up 5, it means my center, if I was at -8 and I move up 5 on the y-axis, now I'm at -3. Because you kind of can even count up, kind of do it in the air, draw yourself a picture. So once I have my new center, I can rewrite my expression. X opposite of h, y opposite of k, And my radius didn't change, so I'm just going to leave it. So the translation is just going to take whatever your center is, and then I go, okay, right and lefts are going to move x, ups and downs are going to move y's. So I'm like, all right, I got this. My new center, if I'm at negative 14, think of a number line, and I go right 4. Now I'm at negative 10. I got closer to getting back to 0. If my y value is at 10 and I go down 5, now I'm at 5. And I use that center, x, opposite of h. Y opposite of k. And leave my radius alone. So, okay. The worksheet that goes with this that you picked up on the way in, there will be a couple of problems now on there that will be a little bit difficult. So let me give you a heads up. On 11 and 12 on the worksheet, you can skip those for right now. We haven't talked about that. But the rest of them, you've got enough information to be able to do this. So use the examples. Have them right there. Go back and forth. Work through some of these because we're going to chat quiz preview and we'll chat some more of this tomorrow.